concentration of that. You agree with that? Everybody? Okay. So if we know these values, we're done. Alright, so we know them? We know them. Why? First of all, we know the initial one. Well, let's stretch it a little bit more. Because I know the way it's done in the books, most of the books and solution manuals, they're done like fast like that, and almost nobody understands how it works, and then you just memorize things. You really don't understand what you're doing. They just put two numbers here and they give you the result. So what's going on here? Right? Is not true? Oh yes, it is true. So let's go slower. So you understood this is the definition, you understood that, right? So now let's go further. This one, do you know the equilibrium concentration of that? How do you know? Somebody said this is equal to the concentration of 80 minus in equilibrium, which is actually what we found here, right here, that value. But the question is why? Why is equal? It is equal. Why? Because this is equilibrium, right? And equilibrium means total. And this is not total. This is the concentration that comes from this reaction, right? How is it? Is it the equilibrium? We have total in solution equal to the one that comes from here, this equation. Because when we say we want ionization, we want the concentration of ionized, and we said that it's equal to the concentration of that. Now you're saying it's equal to equilibrium. But equilibrium is the total, not the one that comes from this. And the total is this that comes from this equation plus that which comes from water. But because that which comes from water is almost zero, because it's 10 to minus 7, suppressed by the formation of this, goes to the left, so it's less than 10 to minus 7, you can ignore it, practically zero from water. Right? And for that reason, the OH minus has to be equilibrium total equal to this. Another way to see it is this. Another way to see it is this. There is electron neutrality. Electron neutrality. So the concentration of the cations should be equal to the concentration of anions. This is from water, and these are from the base. So what we say is that that which comes from the base, this one here, is equal to right? Why is that? Because these concentrations are what? Practically zero, right? You can see it that way too. So, we put the value there. The original is what? Times 10 to minus 12, times 2 times 100. So you find out that it's how much? 5%. So 5% ionization, right? Somebody's talking continuously. It's amazing. Come on, you guys. Everybody does it. I mean, 10 people does it, cannot do it. Okay? Just stop talking. Please. You didn't hear me, huh? No? There was no hair yet. Still talking? Hello? Somebody talking? Now, somebody who remembers something we have said, You can check after this number. We have said that, well, let's see, how much is it? What's the equilibrium question of, no, we can, it's not the same equilibrium question, so we can already forget about it. Okay, so we'll go to C. C says if you get the solution of crystal of solvent hydrogen sulfate, if the pH will increase or decrease. So, what's the answer? How many people say decrease? Raise your hand. How about increase? Not a good answer. Most people do not know. What is the question that you will ask to find out what will the pH do? If it will increase or decrease. What are you going to ask now? What's the next question? If what? If the salt is what? Acidic or basic, right? So let's see. When you have sodium hydrogen sulfate, if it's acidic, the pH is going to go up or down? Down. If it's basic, up. So the only question you have to answer to yourself is this salt, when it dissolves in water, liquid, if that will give you acidic or basic solution. And that depends on the hydrolysis of its ions. In what kind of reaction do the ions react with water? And if they do, what do they produce? Hydronium ions or hydroxide ions? Okay, so that's the question. You can remember it, memorize it, but there is quite a salt, and if you memorize it, you will not be able to remember it that day probably. So you have to understand it. Okay? So, basic or acidic? We have this, basic or acidic, each one of them. We know sodium plus does not react with water. Sodium plus, not sodium, sodium plus does not react with water. We'll talk about it in the lecture. Hydrogen sulfate does react with water. And if it does, in what ways? Hydrogen sulfate can pick up a proton or can give up a proton, potentially. This is theoretically speaking, right? Possibilities, right? This is hypothetical. You can take a proton, so hydrogen sulfate potentially can act as a peroxylary base or peroxylary acid. Now the question is that reasonable? Is this reasonable, the first one? That's not reasonable. Why? Because sulfuric acid is a strong acid. It cannot be in water like this. We know that. It's a strong acid, so its conjugate base is extremely weak. It will not react with water. Right? Sorry, I should have put like this. To make it really right, we should do it like this. Okay? This one reacts with water, right? And creates hydrogen ions. Okay? So H2SO1 with water will give you sulfuric acid and water, 2H minus. Hydrogen sulfate can react with water. And now in this case it reacts as an acid. So here it is acting as a base. And here it's acting as an acid. Right? You see that? Sorry for my mess here. So this is not possible. Why? Because it creates sulfate, sulfuric acid. Sulfuric acid is a strong acid, right? When you have a strong acid, the conjugate base is weak, so it cannot pick up a proton from water and give you this. Can you see that? So this reaction is not possible. But this reaction is possible. So what does that create? Hydrogen ions. What does it mean? That sodium hydrogen sulfate is what? Acidic. So if you put it there, what will happen to the pH? It's going to go down. Can you see how you do it? How about if the problem is asking you sodium sulfate? What is it? Acidic or basic? What is it? How many people say basic? Let me see your hand. How many people say acidic? How many people do not know? Let me see your hand. You do the same thing again, all right? Sodium plus will not react with water. You have sulfate 2 minus, right? Right? Well, this cannot react really as an acid. It doesn't have a proton G to create hydronyl ion with water, does it? So it cannot